All right, let's do these three problems. And honestly, I think number 14 here was done on a prior page, but I'm going to go through it anyway, just in case you didn't see that video. But this is the position of a particle. So I'm going to go ahead into my graphing screen and I'm going to type in the function. So we have x plus 1, open parentheses for x minus 3, and I will cube that one. And then I want to know when the velocity is increasing. So I think last time I showed you the acceleration graph and I looked for where that was positive. This time I'll show you the velocity graph and we'll look for where it is increasing. And I know I want to see on the intervals from 0 to 3 definitely. So I'll go to my window and change it to say -2 to 5, just so I can get a good picture. And I want to see whether this function is increasing or decreasing on these intervals. So it looks like the first derivative is increasing for this section and then again at this section. So I need to know where there's a local max here and the local min here. So I'm going to go to second trace and I'll do max first. And I want to make sure I see that cursor. There we go. That's to the left of my local max. Then I'm going to scale over to the right till I see that cursor again. There it is. So that's the right. And at x equals 1, effectively, I have a max. So where t is less than 1, I have a derivative that is increasing. Let's now find out where this local min is. Second trace. Choice 3 is min. I'm going to scroll to the right here till I see that cursor. And then I'm going to scroll to the right again and hit enter and guess. And that is at 3. So to the right of 3, the derivative is also increasing. So the answer here is D. All right, for the next problem, they're giving us a tangent line in standard form, which we haven't seen in a very long time. And then they're asking us what the limit of this function as h approaches 0 at x equals 2. This you guys need to memorize is the definition of the derivative. And I wouldn't say memorize, you need to recognize it as the definition of the derivative. So they're really just asking what is the slope of the tangent line at x equals 2. So let's take this function and let's solve it for y. So if I put 0.38y on one side of the equation, and on the other side I'm going to have 0.17x plus, let's see, if this goes positive, I need to subtract, subtracting out 0.42, and then I need to divide through the entire thing by 0.38. So I need 0.17 over 0.38, and that is going to be the slope of the tangent line, and let's go ahead and put that in our calculator just on the home screen. 0.17 divided by 0.38, enter, and the answer is 0.447, so we'll go with C, 0.45. Okay, next, how many points do these two graphs have the same slope? Well, to find that out, I'm going to graph both functions and their derivatives. So first we'll do 4 raised to the x. We have 4 raised to the x. And I don't really want to see the function. I want to see its derivative, so I have that derivative highlighted. Then I'll go down here to y4, and I'm going to graph in x to the 4th. And then under y5, I'm going to take the derivative of the function in y to the 4th. So I'll do alpha trace, and then, alpha window, and I'll get the numerical derivative as choice 3, differentiate with respect to x. Now I'll do alpha trace, and I'll choose y4 because we want the derivative of the function in y4, and I want that for all x, so I type in an x there. The only housekeeping I need to do is go up to y4 and unhighlight because I don't want to see the function, I just want to see the derivative. So those are in y2 and y5, and I'll just hit the graph button, see what I see on this window, and I'm really looking for how many times these graphs intersect. So that is the derivative of 4 to the x right there. And then what we're going to have is the derivative of x to the 4th. Aha! Looks like there's one intersection there, but I don't know what happens beyond that. So I'm going to have to change my window. And I don't need anything over here because these two functions clearly don't intersect to the left of the y-axis. So I'm going to change my x to 0 as a minimum and then say 10 as a max. And then I want to just get a really good look at the y value. So I'm going to take it up to 50. I don't know what I need, but I like to take a look here. So here's my derivative of 4 to the x, and here's my derivative of x to the 4th coming in next. I'm probably going to have to change my window to see where these intersect. Okay. I see this one point here, and I'm feeling like that's going to be at x equals 1. I know x equals 1 is going to have one point of intersection, but my gut tells me there's another point up here. Let's do this. Let me find what this intersection point is. Second calc. What's the intersection point that I see here? So let's get really close to the point that we're seeing. There we go. Okay, enter, enter, enter. And that's at 1.25. So that's actually my second point. The reason why I think, I could be wrong. Sorry for doing a little bit of exploration with you guys. Let me just look at the table, see if the table is going to help me at all. I'm comparing these two functions, and I know I have an intersection point right in here. And then do you see how at 3, my y2 is less than my y5, but at 4, my y2 is greater than my y5? That means there's going to be a second point of intersection somewhere between 3 and 4. And I don't know exactly where, but I don't need to know. If you keep on looking down here, you're going to see that my y2, because it's exponential, it keeps on growing and growing and growing, way more than what's in y5. So I know that I'm going to have just 2 points of intersection. The first one is at 1.25, and the second one was between 3 and 4, so there are 2 points.